So let's do some labeling. I will be showing you pictures of people, and you are acting as the classifier, and you will need to label each image with emotional expression, neutral, happy, or sad. So, neutral, happy, or sad? Neutral. Fine. Sad. Got it. And that? Happy. All right. So now, when someone asks you, have you done any data labeling, you can say yes. You have just labeled 3 images. So what is data labeling? It has many forms. You can label images like we just did, or you can label text or audio or any combination of that data. Basically, you can. There are 2 kinds of supervised learning. 2 kinds of machine learning. 2 kinds of machine learning: supervised and unsupervised. To do supervised learning, you need labeled data. So what you just did is assign a label to an image. And historically, data labeling doesn't have a great reputation. It's almost considered something kind of menial and low-skilled work. So let's talk about that. But before we do you like tomatoes? Mixed opinions. So I personally like tomatoes a lot, but that was not always the case. When I was small, I really didn't like them. They like this weird taste and a slimy texture, and I couldn't understand why my parents were sort of encouraging me to eat them. This, so slimy. And that was the case for a while, until one day I tried a tomato, and actually I kind of liked it. And then over time, I ate more and more, and now I actually really like them. So it turns out that your taste changes over time, and something that you didn't enjoy before might actually become rewarding and nice later on. So labeling data is a little bit like that. So if you've if you've built any system that needs data labeling and you've done it, then I'll be really curious to hear your opinion, like how it was afterwards. If you've never done any data labeling, you might not have a sort of good idea for how it works and how it feels like. And it might be, and if you've tried it and you didn't like it, it might be time to try again, because you might find it rewarding. The world changes, and what used to be a mindless chore at some point can become maybe still a mindless chore, but something that's still useful and kind of enjoyable. Just like your diet shouldn't consist of just tomatoes, you shouldn't be spending your whole days labeling data, but your life will be richer if you add some data labeling sauce to it. So we're going to talk about why I think it's important to label data. We'll talk about how complex systems tend to fail, and why nebulous understanding of stuff is a good thing. I'll talk you through an example, how we applied this at Rainforest, where I work, and also mention why Elixir is a good fit for doing this kind of work. So I don't know if you've noticed, but AI seems kind of important these days, and we can't exactly predict what will happen in the future, but it seems like a pretty safe bet that the AI systems will become more and more important over time. And the thing about AI systems is that they need data. And I guess everyone knows that. They need these really big data sets. But I think not enough people appreciate the need for small data. And there are all kinds of unfulfilled data niches in the world. And I want to tell you that you are really well placed to be filling those niches, and that's something you should be doing. And by the way, when I say AI system, I don't necessarily mean something like GPT-4 or Gemini. Of course, those need data, but you're not running them. And if you are, congratulations. But I mean basically any software that uses AI in any capacity, whether you're just querying OpenAI API, or you're using something old school like a linear regression or SVMs, anything like that. If your software is making decisions using something more complicated than a couple of if statements, then you should probably be thinking of that as an AI system. So does this apply to you? I think it does, and we'll talk about that. If you have shipped or you're thinking of shipping any kind of AI feature in your product. One more thing, kind of an aside, but it's an interesting connection. I'm sure you've heard about observability. It's a really sort of, really popular and really well explored topic. What it means to me is basically the ability to ask and answer questions about a production system without necessarily knowing what those questions will be when you build a system. Then you're running in production and you want to have this kind of framework to know what is going on. And unfortunately, this doesn't map super neatly to AI systems. Like you can take an HTTP request and you can trace it through its whole life cycle, figure out all the side effects and database calls, and that's really cool. But you cannot necessarily do that with like an image classifier. You cannot take an image as an input and trace like billions of multiplications on the GPU to then figure out why exactly you get certain output. It's just not feasible. And people are working on interpretability in AI, but it's an active area of research. So what do we do about this? I'm going to tell you a little story about a janitor and a hammer. And you might have heard it or read it online. I didn't come up with it. But the story goes that there is this company. And the company has a really big, complicated machine at the center of its operations. And there is this janitor that cleans around it, maintains the machine. And that goes on for years. And everything is fine. And then it goes on for years. The janitor eventually gets old and retires. And a week after that, the machine breaks. And the management calls on all hands, they try to fix it, and they can't figure it out. So they call back the janitor as an independent contractor the next day. He comes in, he kind of has a little listen, he looks at the machine, he puts his ears to it, and he walks over to a wall, grabs a hammer, just gives it a nice whack in one specific spot, and everything starts running, and the machine works perfectly, and everyone is happy. And then the next day, management gets a bill for $10,000, and they're kind of shocked. They ask for an itemized bill, and they get two items, whacking machine with a hammer, $5, knowing where to whack, $9,995. So in my interpretation of this story, the janitor didn't have this perfect rational understanding of the machine on the component level, how it works mechanistically, but he had this really intimate intuition about it, because he spent years observing inputs and outputs, and he could predict how to fix problems, what will happen in certain situations. So he had this really good black box model, even if he didn't know exactly how things worked inside. And you might think that this kind of thing is an exception, or maybe below you because you're a perfectly rational engineer who doesn't need sort of nebulous intuition. But in fact, this kind of gut feel understanding of complex systems is pretty much the only way we know how to mitigate catastrophic failures in complex systems. So what are complex systems? I think this is my favorite URL on the internet, how.complexsystems.fail. If you haven't read it, I really encourage you to have a look. It is pretty popular, so I wouldn't be surprised if a lot of you know it. It's basically a distillation of years of work by Richard I. Cook, and he was a researcher looking at complex systems academically. So complex systems can be things like hospitals, cities, whole economies. Basically, it's a system that is composed of many parts, and the parts are connected in different interesting ways. Some kind of compete, some collaborate, there are feedback loops, and basically it's really difficult to predict what will happen once you make a change. And obviously we want to avoid failures in complex systems. So this whole set of 18 commandments is like an exploration and a distillation of that. And in our case for AI systems, it's what failure means is kind of a big question, but I don't think we need to be super disciplined about defining it right now. Just think of the system does something that you don't like. So it can be your app goes down, obviously you don't want that, that's a failure. But it might be like giving slightly wrong classifications or catastrophically wrong classifications. Something goes wrong and you don't like it, that's a failure. So I'll talk through some of them. There's a lot of them, I'm going to cover all, but I'll point out some that I think apply to AI systems. So complex systems are intrinsically hazardous, and that means you are going to fail, or your system is going to fail. And that's okay, but you have to accept it. If you strive for no failure at all, you will fail, but you can control the rate of failure. So you can fail more or less, and that's what this whole field is about. And we as humans have dual roles. So we're producers of failure. And I don't know about you, but I have definitely been a producer of failure more than once. But we're also defenders against failure. Sometimes things are this close to failing, and then you notice an alert going off, and you mitigate it, and then things don't fail. And that's a sort of inherent element of these kinds of systems. And we are the adaptable elements. So you have, when you design your system, you think about what can go wrong, and you put mitigations in place, and that's great, and you should do that. But there are things that will come up that you didn't predict, and then your last line of defense is human operators who know what to do with this. And your expertise will be changing. So just like you cannot enter the same river twice, and the world is changing, so your system is going to evolve. And it's important that people who are involved keep up with that and know how things change over time. And finally, if you want to have failure-free operations, you need to fail enough to have experience with failure. So security teams know that, and operations teams know that. They have like blue and red teams and like tabletop exercises to go through that. And that's also why, if you're running any AI system, you need to be exposed to times when things are going wrong, so then you can adapt and understand things appropriately. So this is a bit of a hot take. I think your CRUD app is a complex system. And you might think it's simple, but from the perspective of your users only ever interact with it through, they need the browser, their operating system, their hardware, all the networks and stuff in between, your hosting provider, your backend, your database, and each of these parts is kind of operated by a separate team of humans, and they interact in many different interesting ways. So the whole thing is really complex. And now you're adding another component to it, the AI component. And again, it doesn't really matter if it's like OpenAI API or some linear regression thing. The point is that it's something that is kind of difficult to understand, and the only hope we have for dealing with things going wrong is observing inputs and outputs. So how do we do that? So hopefully I've now convinced you that it's a good thing to do, and from the title of the talk you probably know that the answer is data labeling. That's how you can observe your system and build up this intuition. And if you are at a place where you have like an input and you can pretty accurately predict what the output of your AI system will be, that's a good thing. Or if something goes wrong, you have a reasonable guess for how to fix it, then that's a good thing. You can say you have a good enough understanding of your complex system to react to things. And also I have great news for you that Elixir is an amazing tech stack to build tools to help you with that. And I'm going to talk you through an example from my company, from Rainforest QA. And we have actually done something like this 3 times. Like back in 2015, we were trying to do fraud detection. And we also did that by like labeling a bunch of data ourselves and building a model and shipping it and monitoring in production and labeling more data. A couple of years ago, we did a similar we used a similar framework to do image matching. And most recently, we've been shipping Gen AI features with LLMs to kind of make testing easier, because our product is about testing. And I'll talk about the second one with image matching because it's the most sort of recent and complete example. And to do that, I have to briefly explain how Rainforest works. So I know that you all love writing tests, but sometimes it might be a better idea for a product manager to write tests for you. And that's what Rainforest allows you to do. So instead of working with like DOM selectors, with Rainforest, you just take a picture of the button you want to click on, and then we execute the test based on image matching. And obviously, this has pros and cons. And one of the difficulties is that if you change the margins of your buttons, then the pixels are no longer the same. So how do we find it? And we want to have something that reflects human judgment, when 2 things that are similar to human might look very different on the pixel level. So we have this machine learning model to help us do that. So what happens is we have this classifier on the left, and it is written in Python, I'm afraid. But it does some work, and it does a classification for these 2 images. So it basically gets 2 images, and it tells us, yes, these 2 are the same thing, or they're 2 different things. And then we just log it. And we just happen to be running on Google Cloud, on Kubernetes. So we log it, and then there's this thing called Google PubSub, not to be confused with Phoenix PubSub, totally different thing. But it can take like a log line and do stuff with it. And it's really easy to connect Broadway to it. So we have this pub/sub thing. It basically sends some logged information to Broadway. And then we use Oban to do a little bit of sort of pre-processing to turn that into something that's consumable to a human. And I'll show you how the interface looks like. And then we have a web interface to do that. And of course, we're using live view. So then an admin, like me or someone from the team, comes along and says, OK, I want to label some data. Show me some random classification that happened in the last day or last week. And then we can really quickly go through some examples and label them. And the nice thing is that we get all this nice stuff that I talked about. So we can monitor model performance over time. Humans are telling us whether the two things should match or not, and we also know what our model said, so we can count how often it's right and how often it's wrong, and then react to that. We also get a stream of new training data. Things change over time, and we get new clients, or our clients update their tests, and we might get the kind of data that we haven't seen before. So then we can get this label data from the human labelers and retrain a new model, and hopefully it will be better. Unfortunately, we don't get $10,000, but we get a lot of intuition from that. So let's see if this will work. So this is the interface. Before I play this, you have on the left, and it's a junky internal tool, so don't judge the design. But the point is that it's really optimized for making quick decisions and with really low friction labeling stuff, so we know what's going on. So on the left here, you see the target that we were looking for. Then we saw the screenshot and we're trying to find the target. We found this bounding box, and we know that we have like two different models, and they both, in this case, they both said it's a match. And then I can press a key on my keyboard to kind of toggle between, and on the top you'll see things. Are things playing? There we go. So if you look at the top here, you see this toggling between. In this case, the images are identical, and there's duplicates because it's just my local environment. And that's it. That's all there is to it. It's not complicated, and it's not supposed to be. The point is that it makes it really simple to quickly label a bunch of data. So then we know what is going on. And what else do we get out of this? So we get something like this. So this is like a graph of our performance. The bars just show how much data we have labeled in different weeks. And as you can see, we haven't been very good recently, but it's because the thing has been working in production for a couple of years, and by now we're pretty confident that we're not going to get huge surprises. So we're not investing as much effort in this now because we've switched to the new features that I mentioned earlier. And then the lines, it's an F1 score because we're doing binary classification, but it's basically accuracy, how good the algorithm is at any given time. And the blue thing is our baseline, what we started with. The orange thing is where we want to be, and the green line is where we are, like where the new algorithm is. And ignore this sort of dip, we just didn't label anything at that time, so that's an artifact. But this is something that you cannot really get any other way. If you have some automated system making decisions for you, so an AI system, sort of by definition, it's really difficult to know whether it's right or not. So with image matching, that's an example. But if you do like summarization, how do you know whether it's a good summary or not? You don't. You need a human to tell you that. If you're doing Whisper, like anything interesting with AI, you need a human to tell you. And that's tricky, unless you, as the team behind the model, puts in the work, and if you create processes for dealing with this, then you can do this. So why is Elixir and Phoenix and LiveView, why are they so good for this? It's because it takes very little effort to build something that is really well tailored to whatever you need to do. So displaying images is easy, but you can add audio, you can use video, and all of these things. It's not about like amazing design. Your internal tools are not going to win any awards, But the user experience of labeling is really important, because if it's a massive pain to label your data, no one is going to do that, and you're just not going to know what's going on. But with LiveView, it's super easy to create experiences that are exactly tailored to what you need, and one person can do it in a couple of weeks, and then you can reap all those benefits. And Oban and LiveView, Oban and Broadway, you might need them, you might not, depending on the setup. But it's a great start because it's so productive. So you are an operator. You have something in production that you need to observe, and a way to observe your AI system is to label your data. So make a habit of that, and you need to have some kind of process for observing what goes in and what comes out. And if you don't do that, you risk catastrophic failure in one way or another. And if you do, you'll likely find that you will enjoy the process. And also, if you're interested in testing, talk to me afterwards. And that's everything. Thank you.
Thank you, Maciej. So we have some time for questions, and I don't think there's any question on Hoover. So any questions from the room? Yep.
Is there a future when you can use competing AI models to classify each other rather than needing humans?
Yeah, there is, and I think that only solves part of the problem, because first of all, how do you know that your other model is correct? And like in some cases, you might know that. Maybe you're making decisions using like GPT 3.5, and then you're verifying them using GPT 4, for cost reasons. So like that might work, but it's only part of the story, because that gives you the metric, but it doesn't give you this understanding of what's going on. So the example with the image matching that I was showing, we've seen this many times where we keep labeling images and everything's fine, and then every so often something changes and we get new kind of data, and only by seeing the examples and sort of building up this intuition, we get this idea like, oh, it seems like this kind of data always fails. So how can we deal with that? Well, maybe we add a new feature, or we change something about our classifier. And that's something that is, like, this kind of intuition is very difficult to build up if you just look at metrics. I think you really need the input-output pairs.
Thanks.
Any more questions? We have a few minutes. So I have one from me. So my question is there any can you share any process of within the process of labeling and then getting those insights on what's basically failing and what fails the most? Is there any process that you have to then capture those insights? Because you can then retrain and you understand it, but is there any way that that's part of the whole process?
So no, we don't have something like this, and I think that's because our team doing the labeling is small enough, and we kind of work together closely enough that we don't really feel the need for something like this. But I could imagine something like, if you label data and that in a way that disagrees with the classifier, you could ask what went wrong. You can have some kind of categorization, or you can just have like an input field, and then someone else could look through all these things and notice that it seems like 80% of things are due to, I don't know, checkboxes not being recognized correctly, or something like that. So that's something you could build, but we haven't done it yet.
Awesome. Any more questions? Yeah.
Hello. I have a question. You talk about we need people to do the data labeling. So how we can trust in that people is labeling every good? Because I agree every right. So when you put in the machine, they're going to how I don't know. You understand the question? How can we know these people is working in the labeling in the?
So basically the question is about the quality of the human labelers. Are they correctly classifying things? It is. it's a problem that has some solutions in some cases, but I don't think there's a general solution. So in our case, this is fine because it's a small team of people who build the model, and we all kind of work closely together, and there's, I think, enough trust to just say, okay, fine, we're just going to trust all the human neighbors. But obviously that doesn't scale. And actually, another part of Rainforest is crowdsourced testing. So like our clients can write tests in plain English, and then we have some crowdsourced workers do this thing, and there definitely is a problem. And the way we deal with it is like an ensemble of people. So every task is not solved by one person, but 2 or 3. And then we look for consensus. So that's one thing you can do. You can sort of build up a whole system for reputation. So if people disagree with each other, someone else can figure out who's right and who's wrong. And if you do that over time, you can figure out that, oh, this person is most likely, correct most of the time versus maybe they need some more training or something like that. So it's really case dependent. But yeah, that sort of, it really matches for the metrics, and if you want to retrain your model, your data needs to be good. And if your label data is bad, then nothing else will matter. You will be in trouble.
Awesome. Yeah, let's give a big round of applause to Maciej.
Thank you.